Well, first of all, thank you for coming. We know Dan Kaminsky is talking next door, and it's that's better? Okay, so thank you for coming. We know Dan Kaminsky is next door talking, and it's quite interesting. If I could, I would have been there and not here, but I have a talk to give. We're going to present to you today Jinx. Jinx is a malware powered by Web 2.0 technology. The major feature which we will demonstrate here today will be the ability to download files from the victim computer.
Please speak louder.
Okay. Okay. That's better? Thank you, thank you. Okay, so Jinx is a malware powered by Web 2.0 technology. Basically, the major feature which we are going to break down here today and discuss is the ability to download files from a victim computer. While downloading files from a victim computer is something no stranger for malwares today, except the Jinx is completely implemented in JavaScript. That means one HTML file and JavaScript in it. Now, the major goal the Jinx is set to compete with is to compete with rootkits and vectors, who can stay longer on the system without getting noticed. And we have a pretty good bet that Jinx can deliver the goodies. This presentation will be made of two parts. First, I will go over the design and the theory behind Jinx. And later on, Jonathan will present a live demonstration and snippets in action. It's a first-of-its-kind malware, and we're proud to be here today to present it to you. As every good story goes, once upon a time, a victim computer has been compromised, and this is how his browser looks like seconds before Jinx has been loaded. Jinx has been loaded. Anybody saw the difference? Take a minute. There is no difference. There is no difference because nowadays we don't treat JavaScripts the way we treat process on the system. We don't monitor them. We don't keep tracks of which JavaScript came from where and what. Basically, it just goes unnoticed as we understand most of the sites using JavaScript. JavaScript, being GUI-less by nature, makes it quite difficult for a person to say at a given moment whether a script has been executed on his browser. Now, for us, this is the fundamental covered element. Although we will present different methods to keep stealth on the victim computer, the inability for a user to say at a given time whatever you're running or not will be served for us. So, JavaScript. What JavaScript is really all about? Well, we've got a high-level language, which means we can do object-oriented fun stuff with it. It's a client-side language, which means your browser ends up executing the code and not the server, as opposed to PHP, for an instance. It's been natively supported by most popular browsers nowadays, Mozilla, Internet Explorer, so basically there is no need for any external modules or ActiveX components to get jiggy with it. It's simply there, waiting for you. Except for some odd small amount of JavaScript functions, basically there is no requirement for any special privilege to execute it, which means websites that are freely can execute JavaScript on your computer without getting any your permission to do so. And one of the most interesting things about JavaScript is that lately, due to all the Web 2.0 hype, JavaScript has been boosted through Ajax. We will talk about Ajax later on in this presentation as a method which allows us to basically get the breakthrough required to make Jinx working. We have a reason to believe that in the near future, JavaScript will be the next assembly language for malware writers. We believe that JavaScript offers a unique package over traditional assembly. For such, you can see the cross-platform feature. JavaScript being cross-platform means malware writers doesn't care about your operation system. JavaScript being architecture independent, which means malware writer doesn't care about your CPU type. JavaScript being unified language, which means there is no need to port in between. The API stays the same. And JavaScript being comprehensive enough by itself, so there is no need in any external modules or DLLs to do the job. It's all come packed in one framework, ready to do the job. Okay, that was a quick overview on the environment and the setup which we're going to be executed. Let's see how it all plays out in code. First, we had to find an entry point. We had to find a place that we can install Jinx at the victim computer. Now, most of the times, JavaScript associated to documents which are representing by different websites. But we couldn't let this happen. We couldn't let ourselves be attached to a certain website, because in that position, we will be affected by the user decision. If we'll close the window or move to another site, we will lose execution. So what we had to do, we had to find a place where we can execute JavaScript and yet stay at the same time unaffected by the user actions. And we found one. We found hiddenwindow.html, home for Jinx. The hidden window file virtually exists in every installation of Firefox. You can see here path to where you can find hidden window on your distribution or platform. It's not only related to Firefox, it basically also exists in Thunderbird, and I believe other Gecko-related products. And what's so special about hidden window is the fact that it's a valid HTML file on the victim file system. It's by default there, and it's been loaded every time the Firefox been launched, which means it takes one instance of Firefox to get hidden window to be rendered in the background, and it takes all the instance of Firefox to be terminated to get hidden window unloaded. A perfect cave to hide in. Now, as I said, our first target, and the primary target, was to download file from the victim computer. Since we're not bounded to any specific URI, since we're not related to any website, our window is the Chrome window. Now, the Chrome window has been a skeleton Firefox object. It's quite restricted. It's restricted in the way that not all the methods can be invoked from the Chrome window. Some of the properties are being marked as read-only. And basically, we are jailed. We are jailed to the resource folder on the Firefox installation. Now, I can promise you there is not much interest in this folder, as we want to access the entire hard drive of the victim, plus some network shares as well. So the goal was to break the Chrome window, to break outside of it. To better understand the jailbreak procedure, one has to understand where the restriction comes from. It comes from the fact that we are being invoked from a special URI called resource. Now, the resource URI, within it, oppose some restrictions of the elements resident inside. Now, as I said before, the hidden window.html file, being a file on the victim file systems, allow us to basically use another alternative URI to be called from. And that's the file one. Basically, we can address hidden window through the file URI, swap the URI handlers, get reloaded, this time as a perfectly innocent file. Here you can see an example of a jailbreak procedure. Basically, the location.search attribute is used as a flag to mark whether we're jail-free or not. Upon execution, we will reach the else statement, where we have the location.href code. The location.href basically switch the URI, means we're going to use the file URI handler, giving a path to hidden window. We're going to append parameter, URI parameter, to mark that we are being jail-free, and this code will be instantly reloaded within Firefox. This time, the location.search won't be empty, and we will be jail-free. Now, it makes sense for the systems and the browser that being a file, we can access other files. And that's basically the logic which we've used to adapt this sort of jailbreak procedure. Now, the file URI itself is being now classified as a security breach. And in Firefox 3, this URI handler has been modified slightly. And currently, Jinx is not quite favorable on Firefox 3. So the breach in the file URI handler is what we rely upon for this version of Jinx to perform the jailbreak procedure. So we already have file in the system, and we want to start reading files, right? So how are we going to read